Yes, thanks everyone for coming. I'll start talking about scaling and how why it's needed for AI agents. Okay, so I think let's just start from. Wait. Okay, screen doesn't. Let's just start from the world that we're living in today. AI being like more and more powerful and more into our everyday life. And as a result, I think it's natural to project that in the next several years, there will be more AI agents coming up, and they will be more integrated into our daily lives. You can imagine AI agents that do things like pay bills, manage your investments, making phone calls for you, and etc. So that's kind of the, I think most people would agree with, like, what's going to happen in the next, several years. Okay, but why do we need blockchain, right? How is that even relevant here? So I think there are mainly two aspects to this. One is that you need an open financial layer that that allows you to truly empower those autonomous AI agents. So if you look at the current financial system today, what is lacking is let's say you want to actually receive funding, or you want to let's say manage the investment and so on. You often need to go through a KYC. For example, even if none of those things are happening, even if you just want to start a business or whatever, that's kind of a necessary step, and that doesn't work very well for AI agents. And what would work very well is this open and permissionless platform where you can just permissionlessly receive and manage assets. Another important aspect is that you need a settlement layer between all of those agents that's neutral and also open. So imagine if let's say we have billions or even trillions of agents, and everyone has tens of them. You need some way for them to kind of talk to each other, connect with each other, potentially also settle agreements among each other. Maybe that's a trade, maybe it's a financial agreement, maybe it's a contract, something else. And you need a place that allows to do the settlement, and you need something that doesn't really bias towards some specific AI agents. And if you have a company behind that, it's likely going to be the case. Okay, so now that we talk about why blockchain is needed, why it's interesting for the proliferation of AI agents, I think it's important to examine what properties the blockchains we actually need. I think scalability here is extremely important because AI agents will be quite easy to create. There'll be some simple interface to create them, and as a result, there will be likely a ton of them. And if we don't have this very scalable infrastructure, then likely you will run into some problem like congestion and degradation of the experience, and overall just won't be able to be the platform where trillions of agents can trade and settle and manage their assets. So yeah, what's unique about Near and why it plays an important role here? I think important thing is that we have this sharded blockchain design from the very beginning, and the throughput scales linearly with number of shards. So as more AI agents come on board, we can scale the blockchain by adding more shards to cater to that need. And something that's much less talked about is that we have this very interesting feature on the blockchain that allows you to pause a transaction in the middle and potentially do some off-chain computation and then come back with the result of the computation and resume the same transaction. And you can imagine this is pretty good for AI use cases. For example, if you need to run some inference, do some database query, number crunching, analytics, you can do that in the same transaction and just pause it there, and then transaction comes back later and resume the same transaction to the end. With that said, I want to talk a bit about what we're trying to do for 2025. There are two main goals for scaling. One is 1 million transactions per second, and two is 200 millisecond blocks. Okay, let's start with the first one, 1 million TPS. So I want to first talk about like roughly how it's going to work. It just doesn't come out of nowhere. So the idea is that we have sharding from the very beginning, and since we launched NiceShield 2.0 last year, the system is fully sharded. So basically, if you add more shards, then you'll get more throughput. And you can roughly think of the throughput as the throughput of the number of shards times the throughput per shard. And we can imagine a world where we have 50 shards. Then if we have 20K TPS per shard, then that gives rise to roughly 1 million TPS. So what do we need to get there? So one thing we need is like actually to get to, let's say, 50 shards. So today we have 6 shards on mainnet. How do we get to 50 shards? So it's through this mechanism called resharding. So basically, this is a very effective, efficient way in the protocol to split one shard into 2 shards based on some boundary account. Right. So let's say we can, let's say we have a shard where it's includes all the account from Alice.near to Bob.near. To split into two shards, let's say we split, we determine somehow that the boundary is B.near. Then the split can be from Alice.near to B.near, and then from B.near to Bob.near. And because of the stateless validation setup that we have today, we also need the resharding to finish in one block, so that it can actually, people can actually validate, the validators can actually validate the state transition. So it's a pretty complex heavy lifting, and I won't go into a lot of the technical details on how exactly that works, but suffice it to say that now we have this mechanism, and it's going to go out to mainnet next week. So in this release, we're going to split 2 of the shards and into 2. So we're going to increase from 6 shards on mainnet into 8 shards on mainnet. The release is going to happen next week. And then, so that's kind of the shard, how you get to many shards, but also that's not enough. You also need to, you also need each shard to be very performant as well. So there are a couple of important optimizations that we're working on. One is this optimistic runtime execution. So this is kind of to run the execution in parallel with the code that actually validates all the transactions are valid. Today they're run sequentially, and that actually just eats up a lot of time when you have, let's say, 10,000 transactions that all needs to be applied. And the other one is actually the parallel execution of transactions and receipt. So actually our runtime, because it's already asynchronous, all the receipts are touching different accounts can be parallelized without worrying about the outcome. So the order doesn't actually matter there. What matters is the order of receipts touching the same account. So we can leverage that and effectively parallelize our runtime. Okay, so let's move on to the next goal, which is 200 millisecond blocks. Just to give some background information on where we how we arrived to this goal. So when we released the NiceShield 2.0 last year, we actually dramatically improved the single shard processing speed because we require all the node to run the chunk application to hold the state in memory. So when they apply a chunk, all the state is already loaded into memory, so you don't have this performance problem where like some database reads might be super slow. So it already become much faster and also much more stable. We didn't change the block time at the time of the release because we want to see how it goes first, making sure that it's stable and everything works properly. So with a number of optimizations we've done since then, we are actually ready to reduce the block time. So we are actually working on this this release that's going to come after the release is going to go out next week. So in that release, we'll reduce the block time to 400 milliseconds. And that's going to be a great improvement over today, which is about like 1.1 second. And it will bring a huge benefit to the entire ecosystem, meaning that all the applications running on Near will be much faster. And especially DeFi application because they often require multiple receipts, multiple hops, and that the effect will be very great improvement. Yeah, because of that, we'll have a sub-second finality as well, which is also very nice, and all of that's going to happen in April. But that's obviously not the end of it. So we're working on this bigger initiative called the separation of consensus and execution. So roughly what it means is that today we have, you produce a block and then people apply the block and then, the next block getting produced through consensus and then you apply that one. So the downside here is that the node are not constantly running the processing transaction. Sometimes they actually wait for a block to be produced. So it's like waiting there idle. So that's what we're trying to do in this big change is that basically we're trying to separate those two things. So what will happen is that consensus will run just separately. They'll constantly run just like all the transactions, and then the blocks were getting produced. And then separately, the execution try to catch up. From time to time, the chunk producer gets some blocks applied, and then they have the new state root, and they would actually submit this state root proposal from time to time on what the new state root may be. This is kind of an overview of like how it works in the sharding setup. So this idea is actually not new. Like people have been working on it, the research related to this for a couple of years now, and there are some blockchains that have already adopted it. But no one has done this for a sharded blockchain. This is primarily because sharding is already very complex, and if you layer this on top of sharding, it's even more complex. And that's why even if you just look at this diagram, you'll probably be like, what am I actually looking at? It is quite complex, but luckily we already have the design fleshed out, and we're working on the implementation of this. So what this means is that it will give us two things. One is that the block will be even faster because we don't actually wait for execution. So that basically the only thing that you do there is just like all the transaction package them into blocks. So it will allow us to run to have an even faster block production time. That's where the 200 millisecond block time goal comes from. But also higher throughput because the nodes will be constantly executing transactions and receipts, and they're not actually wasting any time waiting for consensus to be achieved. So the throughput will be higher as well, and this is also one of the ways we will get throughput improvements for a single shard. Okay, so looking forward, we will hopefully by the end of this year we'll have extremely fast and scalable chain, 200 millisecond block, 1 million transactions per second, and that will be a perfect settlement and financial layer for AI agents, however many they may be. So it's an exciting future to look forward to, and that's it. Thanks.